This is a second semester final exam review, problems 8 to 17. Number 8 gives you a table of the number of hours studied and the score on something called a Regents test. This is a test students in New York take, in case you're wondering. And they want you to describe the correlation. Well, what you're going to do is you're going to put this data into the calculator under Stat, Edit, which is number 1, and then you'll put this column into list 1 and this column into list 2. Well, there are two things that you can do when you're looking at the correlation. One of them is to do the stat plot. So if you go to second y equals and turn the stat plot on, make sure that your now I gotta look at this again. Make sure that your type of graph is the first one as opposed to like a box and whisker display or something else. And then if you go to zoom and find zoom stat, which is probably not on the front screen, you'll have to keep going down till you find it. You'll look at the scatter plot, which you'll notice is not greatly correlated. But the other thing that you can do is you can go back to stat, but this time arrow 1 to the right to calc, go to number 4, linear regression, and you may have to hit enter a couple times before the answer pops up on the screen. But one of the things we looked at was the value of R, and in this case R is about 0.85. The closer that R is to 1 or -1, the more correlated it is. So it's not a strong correlation. It's more of a weak correlation. The closer that number is to 0.5, it's going to be no correlation. Or I'm sorry, I shouldn't say 0.5. The closer it is to 0, it's going to be no correlation. So it's got a correlation. It's not the strongest of correlations, but it's all right. In number 9, in order to find the equation of the line in slope-intercept form that is perpendicular to y equals -3x plus 4 and passes through 8,5, you need to first know what the slope of this line is, which is -3. The slope of the line perpendicular to it is going to be the opposite reciprocal of that slope. Remember, opposite means change the sign, reciprocal means flip the fraction. So now I know what my slope is. What I don't know is the y-intercept. Now I'm going to plug this ordered pair into this equation because I know that 8,5 lies on my new line. So I'm going to get 5 is equal to 1/3 times 8 plus b. So 5 is equal to 8/3 plus b. When I subtract 8/3 from both sides, I'm going to find out that b is 7/3. So y equals 1/3 x plus 7/3 is the equation of the line perpendicular to -3x plus 4, but also passes through the point 8,5. Absolute value problems have two solutions. So we're going to set this up so that there are two equations that we're going to solve. The way it works is you need to isolate the absolute value bars before you do anything else. So you would subtract 6 first. Now we're going to write two equations. One of the equations is the value between the bars could be positive 29 because the absolute value of 29 is 29. Or the value between the bars could be negative 29 because the absolute value of negative 29 is also positive 29. That's why there are two solutions. Well, this is just two general run-of-the-mill algebra equations that you can solve. One of the answers is going to be 34/3, which cannot be reduced. The other answer is going to be 8. Both of these are solutions. Remember, absolute value problems will have two solutions. So in B, the absolute value of x plus 8 minus 2 equals 14. First, you would add 2. You've got to isolate the absolute value bar before you write two equations. My two equations are going to be x plus 8 equals 16 or x plus 8 equals negative 16. So one of the answers is x equals 8, and the other one is going to be x equals negative 24. In problem 11, it says if you were to solve the equation, the absolute value of x minus 6 equals 3 using a number line as opposed to using algebraic methods, where would you start? How would you determine your solutions? Well, this is what I did. I thought about what my two solutions are going to be, and this is how you set them up. One of the solutions is going to be x minus 6 equals 3, or x equals 9. The other one's going to be x minus 6 equals negative 3, or x equals 3. So I know one of my answers is at 3, and the other one is at 9. This tells you how far to the left and to the right of your starting point you're going to go. So my starting point must have been 6. So you must start at 6, and then you go 3 units to the right and 3 units to the left, and that's how you find your two solutions. So then I went and I wrote this generalized equation that said n is your starting point. What if instead this had said x plus 5 equals 2? I would have started at negative 5, and then I would have gone 2 units to the right and 2 units to the left, and that's how I would have found out the answers were negative 7 and negative 3. And then this number tells you how far you go to the left and to the right of your starting point. Number 12. The hourly rate of a waiter is $5 plus tips. So it's $5 the number of hours plus tips. On a particular day, the waiter worked 8 hours and received more than $180 in pay. What could be the amount of tips the waiter received? So more than means greater than, not greater than or equal to. So I would solve this like any old equation, except I'm going to find out that the tips have to be more than $140. So in a multiple choice test, you would want to pick an answer that was actually bigger than 140, but not equal to 140, because of that little phrase, more than, that occurred in the sentence. Number 13, you put up a new shelf that is 21 inches wide to store some of your books and trophies. Each book takes up 1.5 inches, and each trophy takes up 4 inches. Write an inequality showing how many books and trophies you will fit on the shelf. Well, I'm going to call book B for the number of books. And I'm going to call T the number of trophies. So if each book takes up 1.5 inches, I would write 1.5 times B. And I'm going to add that to the amount of space the trophies take up, which is 4 times the number of trophies. Remember, I have 21 inches. So what an equality would say that I only have up to 21 inches and no more. It would be less than or equal to. And this is an inequality that I could use. We have spent a lot of time this school year talking about transformations on graphs. So hopefully at this point in time, no one will get any of these wrong. I want to take the equation y equals f of x, and I want to write it so that it says that it's gone 3 units up. Well, that's adding 3 to the original function. Moving it down 5, that's subtracting 5 from the original function. Going to the left 2, that's a change in the input. So the plus 2 goes in the parentheses. Remember, plus 2 tells me it's actually going to the left. Because if I want to go to the right 7, it's going to be x minus 7. Now let's go the other direction. How about I give you the equation and I ask you for what's the transformation. Well, in 15a, f of x plus 4, this graph would be moving to the left 4. And h of x equals f of x minus 2 would be going to the right 2. The numbers that move the graph up or down are always outside the parentheses. I noticed that the graphs in number 16 are barely visible, so I am drawing them here for you. This is 16a. We want to write an equation that represents this graph. Well, first of all, it's a V-shaped, so it's an absolute value graph. The parent function for the absolute value graph looks like this, and the parent function is y equals the absolute value of x. Well, clearly, this graph has been moved. It's gone 2 to the left and 3 up. And the way you write that is you would write x plus 2 in the brackets, or in the absolute value bars, and then you would put plus 3 outside. But the other thing that I want you to notice is that the graph is upside down. That's a reflection over the y-axis. So the equation that represents this absolute value function is y equals negative absolute value of x plus 2 plus 3. Now, the reason it's just a negative 1 out here, the transformed graph is always this general equation. A kind of represents a slope. So you just look at the slope of 1/2 of the graph, and since the graph goes down 1 to the right 1, down 1 to the right 1, the slope is 1. But since it's opening down, it's negative 1. Here's the graph you should see in V. Alright, so we want to write this equation, and we have to determine how the parent graph has been transformed. Well, first of all, it's gone to the right 2 and down 4. So that's y equals ax minus 2 minus 4. Well, now I got to figure out what a is. Since the graph opens up, it's going to be positive, and a kind of has to do with the slope. So let's look at the slope. I have to go from here to here, up 2 to the right 1. Well, slope is rise over run, then a must be 2 over 1. So the equation must be y equals 2, x minus 2, absolute value of, minus 4. So when you're doing this problem, you need to determine how the parent graph has been transformed, and you need to figure out what the slope is. You only need to pick one side of the V, so it doesn't matter if you pick this side or this side when you find the slope. Just remember, if the V opens up, a is positive. If V opens down, it's negative. In this last problem in this video, the recommended dietary allowance for vitamin C is 5 micrograms per day. Write an absolute value function for the difference between the number of micrograms of vitamin C you ate today, x, and the recommended amount. Well, think about it this way. So let's say you ate 10 micrograms, which looks like this, of vitamin C, but the recommended daily amount is 5. That means you had 5 too much, right? Let's say that you ate 2 micrograms of vitamin C. That means you haven't had enough. You need 3 more. That's why this is absolute value equation. Well, we're going to make x the amount of vitamin C you had, and y is going to be the difference. So the absolute value equation is going to be y equals the absolute value of x minus 5. And that is the end of video 2 of the semester 2 review.